In this lesson, you will identify the metamorphic rocks in your lab kit. Metamorphic rocks form when a parent rock is subjected to high temperatures and/or high pressures. These stresses, especially those responsible for the high pressures that metamorphose rocks, also deform large rock units. In Lesson 2, you looked at both brittle and ductile deformation of rocks. When pressures are applied slowly, rocks will bend rather than break. We call this ductile deformation. Now in Lesson 2, you identified several structures that result from ductile deformation, including synclines, anticlines, domes, and basins. But these images are just idealized sketches. What do these structures look like in real life? Well, first, let's look at anticlines and synclines. If you remember from Lesson 2, compressional stress, or a pushing together type of stress, creates anticlines and synclines. This kind of stress is common when two continental plates converge, such as when North America collided with Africa during the Allegheny orogeny, starting approximately 300 million years ago. That event was the final event during the formation of the Appalachian Mountains. And you can see examples of synclines and anticlines along many road cuts throughout the mountains, like this example here. Now let's take a look at domes. In a theoretical sense, a side view of a dome looks just like an anticline, but you're much more likely to see a dome when you look at it from above. Domes form when the basement rocks upwarp, deforming the sedimentary layers above. Domes are often eroded flat, and the rock layers form these concentric circles, like you see here. In a dome, the oldest rock would be in the middle of these concentric circles. Now finally, let's take a look at basins. Again, in a theoretical sense, a side view of a basin looks just like a syncline. But when you look at a basin from above, you will see concentric circles, just like in a dome. But a basin forms when a load, such as a large accumulation of sediments, causes flat sedimentary layers to subside in a concentrated area, forming a bowl shape. In a basin, the center rock unit is the youngest, which is the opposite of a dome. Here you can see an example of a basin. So we have looked at anticlines, synclines, domes, and basins. Keep these structures in mind as you work through the lesson activities, especially the second activity in the lesson. And as you drive through the mountains in Pennsylvania, look for these structures in the road cuts.